This lecture is on operationalization, measuring your dependent variable. So we've learned what a dependent variable is, and we've learned how to write a conceptual definition of a dependent variable, but that doesn't help us much in research. In research, we have to be able to measure the dependent variable, and that's what this lecture is all about. So your dependent variable is your focus. It's where you've chosen to place your attention. It's important. It means something to you. It makes a difference. So here are some examples from studies you might know. Otherwise, I'm going to link these videos in the lecture. So in the Good Samaritan study that you should have seen, the variable helpfulness was measured by observing whether people stopped to help an ostensibly injured man on the ground. In the Milgram obedience study, after World War II, you've already, of course, read about the atrocities conducted by researchers during that war, but we also have soldiers, just innocent everyday soldiers who tortured innocent people. And when asked why, they said they were obeying orders. And that led Stan Milgram after the war to become interested in this obedience. And so you're familiar with his study, or you will be by watching the video. He found ways to measure obedience in this famous experiment because it was important to know how far people would obey. The Asch conformity study, because so many people in Nazi Germany, like the neighbors, the people just living in the towns and cities, just went along with it. They went along with their neighbors and friends in letting innocent people be tortured right in front of them, or their neighbors be taken away. And so Asch got interested in conformity. To what extent and when do we just go along with the crowd? How far do we go? And so here again, these are just examples of dependent variables and why they were important. Helpfulness, obedience, conformity. So in psychology, our dependent variables are often constructs. And constructs in psychology are just these complex ideas that are just in our head. They're a synthesis of simpler ideas. And they don't have exact boundaries, and we don't have a precise way to measure them, and they might mean different things to each of us. So for example, the variable well-being might consist of aspects of physical health, happiness, mental health, social connectedness, and meaningfulness. And all of those come together to form this kind of mushy idea that we might call well-being. Or the variable creativity might consist of the ability to synthesize, flow, adapt, draw unique conclusions or connections. And again, all those kind of vague ideas come together to form this bigger concept we call creativity. Now, of course, some variables are not constructs, or we're really able to measure them. Age we measure in years, weight we measure in pounds, but how do we measure these constructs? It can be harder, so we need to operationalize them, and all that means is find a way to measure them. We can't directly observe them, we can't put a thermometer in, we can't physically count them or hold up a ruler. And so that's why we have to go through this extra effort to find a way to measure them. So operationalizing your dependent variable, first we'll define it and then we'll give an example. So operationalizing means to determine a process or tool through which you can systematically collect data on processes and phenomena that aren't directly observable. So social anxiety is a construct. There's no thermometer or ruler that can measure it. But we could use a few different things. We could ask people to rate their anxiety on a valid social anxiety scale. That's called a self-report measure. We could count the number of times people avoided social situations over a 1-week period. That's a behavioral measure. We could measure heart rate, perspiration, and other physiological indicators of anxiety in social situations, and that is an example of a physiological measure. A second example, let's say we're interested in the variable aggression. Aggression is a construct. Once again, we don't have a clean way to measure it. So how could we do it? Well, again, we could go to self-report. We could ask people to rate their own tendency toward aggression on a scale that's been validated. We could use what we call a knowledgeable informant. We could ask close others, people who are close to the person we're interested in, to rate that person's tendency toward aggression on a valid aggression scale. So the person could rate him or herself, and someone close to them could rate them too. Lab observation. We could define very clearly specific behaviors that we would deem to be aggressive, and we would have to test this. Like, for example, approaching a person quickly, or entering another's personal space, or leaning over another person. Maybe all of those correspond with aggression. And then we could create a lab situation where aggression might be possible and have trained observers count aggressive behaviors. Behavioral observation. We could develop a proxy measure for aggression that would not hurt another person. So like blasting a loud noise at an opponent who's protected from that noise, but the person who's blasting the noise doesn't know, and we could measure the volume and duration of the noise blast. So these are just some examples that we're going to tease out a little more in our next lecture. So once again, operational definitions, a description of how a variable will be measured that is so precise that everyone will count it the same way. And it has to have two characteristics. One, it has to be quantifiable. There has to be something to count. We have to be able to attach a number somehow to the construct. So when we say measurable, that's what we mean. We have to be able to put a number to it. And then precise. It's got to be so specific, so clear what we're going to count or what we're going to measure that everybody knows exactly what it is that should be counted. So let's tease these out a little more. When we think about quantifiable, we think about 4 different things about the dependent variable that we could measure. And we're going to use an example and definitions of these 4 ways. So our example is, let's imagine that we're interested in a variable distractibility. We want to help support a child in training their own mind to be able to focus, so we think it's important to know how distractible a child is, and so we are focusing on this one child in a classroom. So the first thing we could do is we could use frequency, listed as number 1 here. We could count the number of times something occurs. That's all we mean with frequency. How many? So for distractibility, we could count the number of times a student looks away from the task in a 1-hour period. That would be an example of using a frequency count. The second way is we could measure duration. We could measure how long the behavior lasts or how long anything lasts. So we're just start time at beginning to end. And for the example of distractibility, we could count the number of minutes a student's eyes remain on the task at hand. And that would be the duration, counting time. In the first example, we're counting incidents. Latency, measuring how long between a stimulus and a response. So like a delay, you can think of delay, latency. And our distractibility example, we could count the minutes between an instruction and a response. So again, we're counting the time in which something isn't happening, like we're counting a delay, even though we're still counting time. And the fourth way is intensity, measuring how severe or strong a response is. And in this case, we'd probably have to have some sort of a scale, so we could measure how distracted the child has gotten on some sort of a rating scale. Like we might have a scale of 1 to 5 for the intensity of a given distraction, with 1 might be like a quiet distraction, only the eyes of the child are diverted, whereas 5 might be changing location, disturbing others, and maybe we would define the stages in between to rate intensity. You can see the common feature in all of these is that they have numbers attached to them. They're quantifiable. The second criterion is that the operational definition has to be precise. So by precise, we mean that the dependent variable is so clearly operationalized that anyone, anywhere, with some very basic training would know exactly what to count. Let's go back to this distractibility example that we've been using, and imagine that we decided to use the first one, the frequency one, the number of eye diversions, as one of several indicators of distractibility. So let's start with this operational definition. Eye diversions, the number of times a child's eyes leave the task during a 1 hour period. So is this precise enough that anyone could count it? Maybe, but maybe not. For example, if somebody comes into the room and the child's eyes look up to see who came in, they look up at this disruption, do we count it? That's not clear in our operational definition. If the child glances away for just a split second, do we count it? Or must the eye diversion be longer? If the child closes his or her eyes, do we count it? Or must the eyes be open to be considered an eye diversion? So you see the problem. So some of these problems are solved while you're training the raters. But in this case, I think there are enough questions that we would probably need to clarify this operational definition so that people know exactly what to count. This might be coming up a more clear version. Eye diversions, the number of times a child's eyes leave the task or close for 3 seconds or longer during a 1 hour work period in the absence of a physical disruption in the classroom. So maybe that's a more clear definition, and maybe if we were really doing this, we would work on this a little more. Now, I want to tell you that we're going to come back to this operational definition again in the next lecture because it still has some problems that we need to discuss. So let's explore a little bit some examples and see if we can decide if it is an operational definition. So our criteria are, is it measurable or quantifiable? Is there some way to use numbers to measure the variable? And secondly, is it precise or defined clearly enough so that anyone could measure it? And so here are some examples. Let's say we have a variable credits, meaning college credits. And we're going to define it as the number of credits a student has completed in their entire college career with passing grade. So is this an operational definition of the variable credits? I would say yes. The quantities will be the number of credits, and the way we're going to count them, the credits that we will count are precisely defined. Maybe something would come up later. For now, I think this is a good operational definition. Variable memory. Measured by scores on a backwards counting memory task that has been validated by previous researchers. So you might look at this one and say, well, I don't know what this task is. And if you were writing a paper, you would describe this task. But if we have a valid task that's been validated by previous researchers, that's probably good. And we'll talk about what validation means later. Variable is happiness. We want to measure happiness. And we write for our operational definition that we're going to measure it by seeing how happy someone is. Is this precise? Is it measurable? Do we have something to attach a number to? And is it clear enough that anyone could recognize it? And I would say not at all. This is not at all an operational definition. What does it mean to see how happy someone is? It's very imprecise. We don't see any numbers. Variable, cooking skill, measured by whether someone is a good cook. Here again, I'd say no. I don't know what to put a number to. I don't know what the number is going to mean. Good cook is very subjective. It's in the eye of the beholder. This one needs a lot of work. E, the variable is mask wearing, and we're going to measure it by the percent of time someone wears a mask covering mouth and nose when entering a public space. And I would say this seems good. It's clear when we'll count the data, when they're entering the public space, and what exactly we will count, but the mask has to be covering. I think it's pretty clear. It's a good starting point. And that's the end of this, so continue on to the next lecture.